Is conjugate acids and bases, and there's a couple of things that we need to know in this that could slip your eyesight. First thing we need to know is that reversible reactions are part of conjugate acids and bases. So the reversible reaction symbol is this symbol here. It's the double arrowhead to the right and to the left, showing a reversible reaction. Acids change to conjugate bases by donating a proton, a H+. So we'll see that in some of the reactions, but that's what you've got to remember. Acids change to bases. Their definition is that they donate a H+. Bases change to conjugate acids when they accept a proton H+. So that's what you've got to bear in mind when you're doing the conjugate acids and bases questions. Okay, so be aware that in this question you do see reference to reverse reaction, just exactly as I mentioned a moment ago. This is the symbol for a reverse reaction, and I've just included some over here to explain acid and conjugate, acid-base conjugates. So we'll have a look at that. Okay, so and just look at this equation here. On the left hand side of the equals that we have here, are the arrow that we have here. This is known as the forward reaction on this side of the equation, and this side of the equation is known as the reverse reaction. I'm making reference to that over here as well, but just to be aware of that. Reverse reactions being the case because, just because you have reactants making products, that doesn't mean that the products themselves then can't react and reverse and become the original reactants. So this is the whole idea behind reverse reactions. An acid is a proton donor, as we said earlier on, and a base is a proton, a H plus acceptor. So bear that in mind when you look at this equation then. Very simply, in the forward reaction, I am saying that this substance here is an acid and this hydroxyl group is a base. Now the reason for that is that this substance here is donating, just follow the line there, it's donating hydrogen, a H plus proton, and this is accepting, so that means that it's a base in the forward reaction, acid and base. And you see that that's the case. The OH minus has accepted the proton, which is the definition of a base. So this is the acid, this is the base. This donates the proton, this accepts the proton. Very simply, in the reverse reaction, what I'm saying is that this is the acid and that this is the base. Reason being is that the H2O is donating a proton, follow the arrowhead, and you see that it's donating a H plus to the carbonate group, the CO3. And if you look at the other side of the equation, you see that yes, the H2O has lost a H, and therefore it has donated a H, which makes it an acid, and this is a base. Okay, so you see that the CO3 was an acid, the HCO3 was an acid in the forward reaction, but the CO3 in the reverse reaction is actually a base, which means that they are the opposite of each other, and this is what a conjugate is. They're the opposite of each other, and therefore these two, the HCO3 and the CO3, become what is known as an acid-base conjugate pair, and you see that over here. Conjugate pair is HCO3 and CO3. And look again, if you look at the forward reaction, you'll see that the OH was a base, but the OH, which had turned into a H2O, in the reverse reaction behaves like an acid. So this is what's known as an acid-base conjugate as well. Okay, and I've got that highlighted over here. So this is another conjugate pair that we have. In the next question is very similar as well. The H3O donates a proton from here, and you can see that to the HCO3, and you can see that because the product of that is H2CO3, which means that this one has accepted a proton, a H, so it's behaved like a base, and this one has behaved like an acid. It's donated a proton. Okay, so while you look at the reverse reaction, you see that the H2CO3 behaves like an acid and the H2O behaves like a base. Why is that? Because the H2CO3 donates a proton to the H2O, and in the reverse reaction the H2O becomes a H3O because it's accepted a proton, which means that H2O in the reverse behaves like a base because it's accepting a proton, whilst H2CO3 is like an acid because it's donating a proton. And there you see the conjugate pairs. I've just linked them then with color-coded arrows, and I've color-coded them below as well to show the pairs written as well.